Differentiation, Part 6. In this session, I would like to introduce what is second derivative of a function. If I have a function f of x, what is the notation of the first derivative? Okay, we try to use d over dx to represent the derivative. Okay, this is the notations. What is second derivative? That means after doing the first derivative, I try to find the derivative again of the new function. That means this part. So second derivative, that means I want to find the derivative of the first derivative. Okay, so make it simple. What you can see now we have 2d here and then 2dx. We can combine the notations, become d squared over dx squared. And then this is f of x. So if I ask you to find this part, what is this? That means find the first derivative. After that, find the derivative of the first derivative. And let's see the first example. I want to use the for exercise to illustrate. For exercise 19a, find the second derivative of the following functions. That means I need to find dy over dx first. Simple. Constant is equal to 0. So 0 minus 2, and then write down the degree and degree minus 1. And then plus write down the degree. The degree is equal to, is not 2, is to the power 1 over x squared. That means to the power negative 2. So negative 2 and degree minus 1. So simplify it. This is 2x negative 2 minus 2x to the power negative 3. Second derivative, that means I need to find the derivative of the first derivative. So the notation like this. What can we do? Find the derivative of this term. Easy. Use the basic power rule. So write down the degree and degree minus 1. And negative 2, write down the degree and degree minus 1. So negative 4 x to the power negative 3 plus 6 times x to the power negative 4. Okay, now we can go back to the first example. Example 4.22. Find the second derivative of these functions. Maybe you can use quotient rule, but if I were you, I will change these functions like this to the power negative 1. I can use power rule and train rule without using quotient rule, because the numerator is equal to 1. So d over dx the first derivative. We cannot use power rule directly because the base are not equal. So you need to use chain rule to change it. And then, so widen the degree minus 1, and time, this is 2x. So it's 2x, negative 2x over x squared minus 1 squared. I want to find the second derivative. So you need to find the derivative of the first derivative. Now this time I will use quotient rule. Minus this part I want to jump to the answer directly. Is 2x squared minus 1 to the power 1 and then 2x, because I need to apply train rule. I have already mentioned how to simplify this term. Can you see the numerator we have common factor x squared minus 1, x squared minus 1, and then maybe negative 2, so I can take it out. Take out negative 2, x squared minus 1, so the first part remain x squared minus 1, and then the second part remain negative. I have already take out negative 2 and this part, so remain 4x, so minus 4x. Then you can cross out 1 become 3. And so the final answer is negative 2x squared minus 4x minus 1 over x squared minus 1 to the power 3. Now you may pause the video and then do for example 19, similar to the previous one, but you can find if you want to find the second derivative, and maybe sometime a little bit complicated, because after finding the first one, okay, easy, but finding the second one, maybe you need to use quotient rule, just like the previous example. Try to pause the video and try. Okay, let's see the answer. Okay, first derivative. I will change this one to 2 minus 3x squared to the power 1 over 2. So, if you want to find y dash, you need to use train rule, write down the degree 1 over 2, and then degree minus 1, train rule, according to the train rule, remain negative 6x. I will simplify it. This is equal to negative 3x over, because I need to find the second derivative, so I will not use product rule, because sometimes it's quite difficult to simplify it if you use product rule. But this part I'll change to quotient rule. Okay, maybe more easy. You can compare if you have already finished by the product rule. Maybe you do not know how to simplify this one, but if you change this one, you can see easy to simplify this one. So, I also want to emphasize, maybe you can use y double dash to represent second derivative. Quotient rule. One over 2 squared is to the power 1. And then write down the denominator first. And then time the derivative of the numerator is negative 3 minus negative 3x. Write down the degree minus 1. According to train rule, remain 6x. I have already mentioned that how to do the simplification of the numerator. Take out the sorry, this is 2. Take out the smallest power. This is -1/2 and this is 1/2, so you may take out -1/2. And take out -3. For the first part, we remain 2 minus 3x squared. And then plus, because I have already taken out -3, and then this part, so we remain 1/2 times this term times negative. So it's plus 3x. Sorry, this is 1/2. Take out -1/2. So the denominator becomes 2 minus 3x squared to the power 3/2. And -3, then -3x squared plus 3x plus 2. Okay, this is the final answer. Okay, the last example, I want to live it and try to do it. Find a 4x 20. Give you the function. Prove that this part is equal to 0. Try to find the first derivative and the second derivative of the function and substitute it to see it is equal to 0, because prove that you must find that the function is equal to 0. Okay, check it.